Hey y'all, we are going to be taking notes on 4.7 day 2, where today's objective is to solve polynomial equations other than quadratic. It is actually incredibly similar to 4.7 day 1, so I'll even put that like 4.7 day 1, just a slight difference where they're not literally saying solve an equation. They're saying find the zeros of the equation. So it's just one extra step from yesterday. And here's the step. So this right here is a function, not quite an equation right now. So if the directions are find the zeros, you better first make f of x equal to 0. And now you've turned it into an equation. So then you factor that equation, and then you use the zero product property. X minus 0 equals, x minus 6 equals 0. X plus 2 equals 0. You solve both of them, and you get x equals 6, and you get x equals negative 2. So your solutions are 6 and negative 2. So remember that I told you the word solutions is like the word roots, is like the word zeros. So if you want the technicality, I would say this is what you're solving when you find your solutions. But if it starts like this, you're technically finding zeros. That's what you're doing. So the reason you're finding zeros, okay? Now, again, sidebar. Let me just write sidebar. If it was written like this, your directions would say solve. And your answer would be 6 and negative 2. But because it's written with the f of x, it's just saying find the zeros. So the reason we're finding the zeros, so technically these are the zeros, and over here, these are the solutions. I use the words interchangeably. Why do we do all this? We do this is another sidebar, because if I wanted to graph y equals x squared minus 4x minus 12, you could also call it f of x. You would start graphing it like as you know to graph a parabola in the same way. But you'd have the 6 here, and you'd have the negative 2 over here, and this would be now the x-intercepts right over there. So the x-intercept would be 6, 0, and negative 2, 0. So remember, we're finding the solutions to this, right? So that we can find the zeros to this, so that we can graph the x-intercepts to this. These are how these are all related. So you can see that what I'm not going to do all these problems because they're not necessary to do. Just doing a couple of them that, like that one's quadratic. I'll do this one because it's quartic. Remember, we're finding the zeros. So if we're finding the zeros, we're replacing f of x with 0. And then we're just going to factor this, where we take out our GCF of x squared, and we get 6x squared plus 7x plus 5. Do you remember that thing I told you also? The fundamental theorem of algebra says, if it's to the 4th power, I'm going to need 4 solutions to this, or 4 zeros. So hopefully I'll find 4. So when I go to factor this, I get x squared, and you could do the work of slide divide or trials, and get that this is 3x plus 5, and this right here is 2x minus 1. After you set all of these equal to 0, x squared equals 0, 3x plus 5 equals 0, and 2x minus 1 equals 0, these are your zeros. A 0, a negative 5/3, and a 1/2. So remember I said I wanted 4 solutions. Well, this one technically is a double 0. Now before you were calling it a double root. So we'll just write that word double zero. I don't mind if you get the word double zero and double root mixed up. So I don't want you to get hung up on it. I just want you to realize that that's the second root right there for 4 of them. So you need 4. So there's 1 and 2 and 3 and 4. So you do have to have that DZ or that DR there. Now, if you want to actually know what this means in the world of graphing, because notice how 2 solutions meant it had 2 x-intercepts. Well, these aren't 3 solutions. These are 4 solutions. So if you're going to go and graph this somewhere, and you're going to graph it at 0, and you're going to graph it at negative 5/3, and you're going to graph it at 1/2. You don't know about end behavior yet, but when you do know about end behavior, this is what the graph could look like. You're not there yet, so I don't want you to get upset if you don't know how to do it. But when the graph is ready to come up again, it's going to just touch the 0. See how it's going up and it's touching it one time? And when it comes back down, it's technically touching it another time. And then it goes through that one. And that technically gives you 1, 2, and 3, and 4 x-intercepts. It's really 3 x-intercepts. But notice it. This one here, it touches because it's a double root. And this one, it goes through. And on this one, it goes through. And we're going to actually talk about this more another time. So I don't want you to worry about the graphing part. But I do want you to understand that we're solving, we're factoring so we can solve. We're solving so we can find the zeros. We're finding the zeros so that we can eventually graph. So if you were to factor this one is you would take out this x minus 2 from here. Well, first we're going to find the zeros. So let's replace, if you can see that 0, f of x gets replaced with 0. Then I'm going to pull out an x squared, leaving me with an x minus 2. Oh, that's actually just an x minus 2 here. And then that's x minus 2 squared minus 1. And that actually continues to factor. So that's x minus 2 minus 1, x minus 2 plus 1. And then when it all washes out, it's x minus 2, x minus 3, and x minus 1. You will, of course, show this work, x minus 2 equals 0, x minus 3 equals 0, x minus 1 equals 0, and you show the work of solving, and you'll get your zeros of a 2, a 3, and a 1. Nothing I want to graph right now. Over here, if I were to turn this into a 0, then I'll factor this as x squared times x minus 1. So my factors, x squared equals 0, x minus 1 equals 0. So my solutions are 0 as a double 0 and 1. So that's why I have 3. There's 3 for the fundamental theorem of algebra. So that's 1, 2, and 3. We won't graph that right now. Again, the graphing isn't something that I want you to get hung up on this point of the game. Okay, so let's take a look at a couple of others. Let's take a look at number 9 and number 10. We don't have to do all these because it's just, you know, same old, same old. We replace the f of x with 0. We factor this into 5x squared with an x minus 4. So therefore I get 5x squared equals 0, x minus 4 equals 0. Here you can show your work that x equals 0 2 times, and then you add your 4 to both sides, and you get x equals 4. So you would write your solutions as this, 0 as a double 0, and 4 as its own solution. Now, as a single root or a single 0. Again, we might as well look at the graphing. You're not responsible for it right now. You'll be responsible for graphing in section 4.9. So we might as well just take a look at it while we're at it. So if someone told you they wanted you to graph this, like such, and I knew it was going down here and up here, another thing I'll teach you. So there's my 0, and there's my 1, 2, 3, and 4. Now, it's not going to go through the 0 because it's the double root. It's going to go up and touch it, come back down, and somehow it has to go up to the 4. We don't know how far this comes down. It could come down here and here. It doesn't matter. It does matter eventually, but not right now. So let's do this last one. And I want to remind people who have trouble kind of visualizing that x squared minus 3 could be a factor of something. X squared minus 3 can be a factor when I have it over here. Like here's this factor over here called x minus 2, and we just pulled it out as a GCF. But this one, this next one is not pulling out a GCF over here. This in Delta Math has a name. They call this one, I never had a name for it until I got into Delta Math, and they call this one factoring by structure. So what you can think of this one as is this: x squared minus 1 or plus 1x minus 2. So how would you normally factor that? You'd call this x plus 2, x minus 1. Except for the fact x squared is x squared minus 3, and it's squared. So instead of saying x plus 2 and x minus 1, you are going to stick on in there x squared minus 3 plus the 2, and x squared minus 3 minus 1. So you're sticking in a binomial instead of the x itself. Again, that's called factoring by structure in Delta Math. So I'll always refer to that as factoring by structure. So if we simplify that, we get x squared minus 1, x squared minus 4, and that equals 0. So this factors further into x minus 1, x plus 1, x minus 2, and x plus 2. And that equals 0. So when you go and use the zero product property, you'll say x minus 1 equals 0, x plus 1 equals 0. I'm going to solve those so you see that I also do the work. And then you're going to say x minus 2 equals 0, so you add the 2 to both sides. And then the x plus 2 equals 0, so you subtract the 2 from both sides. So your solutions, or your zeros in this case, are a 1, a negative 1, a 2, and a negative 2. And those are finding the zeros. Well, that's my last problem. So all I'm going to tell you eventually is we're going to graph these as x-intercepts. Last problem as x-intercepts. But tonight's homework is just this over here, because you've already done this, 4.7 day 1. Now you're going to do 4.7 day 2, where you're doing 29 through 49 odd, where you're finding the zeros.